Okay, so let me introduce myself. My name is Aishwaresh. I am here to teach you industrial engineering subject. So you might all be knowing that today we are going to start industrial engineering. Okay, so again, one of the most important subject. So all the subjects, okay, so you cannot neglect any subject. All the subjects are important. Okay, so I'll just write my name here. So I know you might have not understood. Okay, so my name is Aishwaresh. I'm here to teach you industrial engineering. So basically I have done masters from National Institute of Technology, Nagpur itself. Okay, NIT Nagpur. That too from industrial engineering stream. Right, this is my brief introduction. Okay, so I hope everything is fine. So let's start with our subject. So I'm hoping that your preparation is going very well, right? So in between, I'll be giving you some preparation tips also. Okay, so that will be very useful for you. Okay, so you should spend your time very wisely, right? Okay, so let's start with our subject today, industrial engineering. Okay, so maybe you might have studied this particular subject in your semester, right? So I hope some of you are pass out students, some of you are third year and fourth year students. I know, so combination of all of them are here. Okay, so keeping all of them in my view, I will be taking this subject from the basics itself. No need to worry. Even if you have not heard the name of the industrial engineering subject, you can follow each and every concept which I am going to take now. Okay, so no need to worry about anything. So I will be taking from the very basics. Okay, so we'll be starting from the basics and we'll clear all the concepts as simple as possible. Okay, so again, as far as GATE examination is considered, you should not neglect any subject. Okay, so maybe previously, like before some 5-6 years, okay, so there was a scenario that people or students were neglecting some subjects. Okay, so which were having less weightage marks. Okay, but it is not now. Okay, so as far as the competition is considered today, okay, so you should not neglect any subject. So not only the subject, okay, even you cannot neglect some topics also from a subject. Okay, so because we don't know from where a 2 marks question can come into the GATE examination. Okay, so even a 2 marks will change your rank drastically. Okay, so you should not neglect any subject. Each and every subject which is present in GATE or your syllabus, it is very, very important. Okay, so coming to this particular subject, so any idea what is the weightage for this subject? So let us have some interaction, okay, or basic introduction about the subject before starting it. Any idea what is the weightage for this particular subject? Okay, 4 to 5 marks and 5 to 6, 6 to 7, 4 marks, right? Okay, so on an average, okay, on an average we can say that this subject is having a weightage of around 6 to 8 marks. Okay, this subject is having a weightage of around 6 to 8 marks. So I am saying on an average, okay, like if you consider 2019, in 2019, so recent paper, last year paper, okay, so there it was asked for 4 marks and 5 marks. Okay, so I hope you know that we are having 2 papers or 2 sets in GATE examination, mechanical paper. Okay, so in one set it was asked for 4 marks and in the other set it was asked for 5 marks. Okay, so it is little bit less. Okay, so but in 2018 it was asked for 6 marks and 6 marks. Okay, and in 2017 it was asked for around 7 marks and 4 marks, I guess 4 or 5 marks. Okay, and again in 2016 also it was something like this. Okay, and in 2015, okay, if I take 2015, I'm just giving you for your reference, okay, so that you can understand what will be the possible weightage, okay, of this particular subject in GATE examination. But in 2015 you got 7, 8 and 9 marks. Okay, so in 2015 we had 3 papers, 3 sets. Okay, so in one set you got 7 marks, in another set it was 8 and 9 marks. Okay, so you can guess the minimum weightage is around 4 marks of this subject. Okay, and the maximum weightage it can go up to 9 marks. Okay, so most of you, I know most of you might be, some of you might be thinking that this subject is not that much important for GATE examination, so why can't we neglect this subject? No, that is not the case. Okay, so you can see here, you cannot predict or you cannot say, okay, so for how many marks next year you can expect, questions from this subject. Okay, like that you cannot predict anything. Okay, so you can see in 2015 it was asked for 9 marks also, right? So that means you should be prepared for worst cases also. Okay, so if you neglect this subject, maybe there is a possibility that it may come for 9 marks. Okay, so then you will be losing 9 marks. Okay, so should not neglect any subject. So as far as this industrial engineering subject is considered, okay, so this is a very simple subject. Okay, in the sense, simple subject in the sense they cannot twist questions. Okay, so this data just I am giving you for your reference. Okay, so that you can make some preparation plan. Okay, right. So I was talking about the difficulty level of the subject. So as far as this industrial engineering subject is concerned, so it is very simple subject. Okay, simple subject in the sense they cannot twist the questions from this subject. Okay, so if you take any other subjects, what will happen that they can twist the subject, or else they can twist the questions which they are going to ask from that particular subject. Okay, so twisting in the sense they can ask some tricky type of questions. Okay, so there is a possibility that they can frame tricky type of questions from other subjects, but from industrial engineering subject, so there is a very few probability is there that you can get a very tough question. Okay, so if you are done preparing industrial engineering subject, definitely you can score 90 to 95% of the marks which they are going to ask from this particular subject, because every time they will be asking very simple questions. Okay, so you will come to know, we will see all the GATE previous year questions, almost all the GATE previous year questions. Okay, so that you will be getting some idea, okay, how they are going to ask questions in the GATE examination, right? So let's start. So if you want to copy, maybe you can copy this part. Okay, so I'll wait just for some seconds. It's just for your reference. Okay, no need to worry much about this. So this just I have given you. So because some of you might be thinking that industrial engineering is having less weightage. Okay, so it's not like that. So previous year it was for around 4 to 5 marks, but it is also very good weightage. 4 to 5 marks is also a good weightage. Okay, so on an average you can expect 6 marks from this subject, 6 to 8. Okay, so maybe in worst cases it can go up to 9 marks also. Okay, so really if you are getting a 9 marks, if you are getting 9 marks from industrial engineering, it is really a blessing for you. Okay, because from industrial engineering you can expect very, very simple questions, right? So let's discuss about syllabus first. Okay, so I hope most of you might have gone through the syllabus. Okay, so anyways, we'll discuss the syllabus first before starting. So how we are going to complete this subject? Okay, so what is the flow? Okay, so everything else we'll discuss now. Generally, so when you go through the syllabus of GATE 2020, right? So you can see this syllabus is divided. So the syllabus of this subject is divided into basically 3 parts. Okay, the first part is operations research, and the second part is inventory control, and the last part is PPC, which is production planning and control. Okay, so I will be listing the subtopics of this major topics also. So under operations research we are going to study CPM and PERT, right? So these are the subtopics of this particular operations research part. Okay, under operations research we are going to discuss CPM and PERT and network flow models, linear programming, then transportation models, and then assignment models, and then queuing theory. Next comes inventory control. Under this we are going to discuss, right? So these are the subtopics which we are going to discuss under inventory control part. Under inventory control, we will be discussing deterministic models of inventory control, and then second one probabilistic models of inventory control, and then selective inventory control techniques. Under PPC, production planning and control, we will be discussing these topics. Okay. Under production planning and control, we are going to discuss these chapters. So first one is sequencing and scheduling. So this is one chapter, and the second one is forecasting models. This is one more chapter, and the third one, this APP, MRP and break-even analysis, this we can consider as one separate chapter, right? So APP represents aggregate production planning, MRP represents material requirement planning, and BEA represents break-even analysis. Okay, so this is our syllabus, so which we are going to study for the GATE examination, right? So you can copy this. So our flow of the subject will be in this manner only. We will be starting with operations research part, okay, and we'll complete all these parts, all these subtopics. Then we'll move to the inventory control, there we'll be completing all these topics, and then finally we will reach this PPC part. Okay. So in your syllabus, I mean as far as your syllabus is considered, operations research part is having more weightage. More weightage in the sense more topics will be there. Okay. So we'll be spending more amount of time on operations research because it is some amount of lengthy part. Okay. So as far as compared to inventory control and PPC, this operations research part is having around 60%. Okay. So around 60% of the time we'll be spending only on this part. 60 to 65 you can say. Okay. 65%. So remaining percentage of time we'll be using for, or we'll be spending on these two parts. So these two are little bit of small parts when compared to this operations research part, right? So hope you understand this, right? So first you can just copy this syllabus, okay? Then we'll start our discussion, okay, on industrial engineering subject. In the sense, what is the meaning of this subject? I mean, what is the objective or what is the aim of this particular subject, right? Or else why we are studying this subject, okay, what is the purpose? So one purpose is to crack gate examination, that is different. But I mean, what is the use of this subject in industrial industries, okay? So how can we apply these tools and techniques which we are going to study in this industrial engineering subject in industries? All these things we'll discuss now, okay? And then we'll start with operations research part, right? So please copy this and let me know if you are done copying, right? So done, fine. So let's start with the aim or objective of this subject. So anyone, maybe you might have heard this, you might have heard the name of this particular subject, industrial engineering, right? Or maybe you might have studied some of the topics also from this particular subject. I hope, like some of you might have studied the subject PPC, okay? Some of you might have studied the subject operations research, okay? So I hope maybe you might have studied or you might have heard some of the names, I guess, okay? Maybe you might have heard some of the names of these topics, okay? Or maybe you might have studied operations research in your semester, or maybe in your, or maybe PPC subject in your semester, right? So even if you're not studied, well and good, it is okay. So no need to worry. But so people who know something about this subject, can you give any answer? Like what is the aim or objective of this subject? So in brief, so what will be the aim of this subject or objective? I mean, why we are studying this subject? That we have to know, okay? So anyways, before starting or before studying any subject, you should know why you are studying this subject, okay? So not only for the gate examination, okay, but practically where can you apply these things that you should know, okay? Whenever you are studying anything or any topic, you should be knowing where I am going to apply this particular subject or where I am going to apply this particular topic, okay? How can I use this particular topic in industries, okay? That part you have to think, okay? So otherwise your thinking will not develop, right? So please try to answer, even if it is wrong, that is okay. I'll try to correct you. So what will be the aim or objective of this subject? So why we are studying? So please reply something. So even if it is right or wrong, no need to worry about that. So Syed, you are saying that optimization of production. Very good, very well said. So I'll write that statement here if you want. Optimization. So you have said one word which is known as optimization, okay? So optimization of, we cannot say it is production, okay? So optimization of processes. So in industries, you can see or you can come across so many processes, like drilling is a process, milling is a process, everything. So every operation which you are performing on any component, it is a process, okay? So whenever you are performing some process or whenever you are doing some process or operations, you can optimize those operations or you can optimize those processes. Now, what is meant by optimization? So so briefly I am saying that the objective of this particular subject is optimization of process, right? Optimization of any process which we are doing in industries, right? Now can you say what is meant by optimization? Any answers? What do you mean by optimization? So we got one new word. Let us discuss this word also because it is important. Everywhere in our industrial engineering subject, we will be using this particular word optimization. Improving efficiency, optimization in the sense improving efficiency. Okay, so optimum usage of resources, very good. Okay, optimum utilization of resources, fine. Help in decision making problems nearby. Okay, good. Something close you are getting, very good, very good. So what will be the, I am just asking what is the meaning of optimization? In general, English meaning, optimization in the sense, So this is very important. This you have to understand, okay? Because when we go to the further chapters, okay, we will be using this term optimization, especially in linear programming. We will be using optimization word frequently. Very good. Best possible, anything best possible. Okay, fine. Optimization in the sense, it may be a maximization or it may be a minimization. It may be a maximization or it may be a minimization. Generally, whenever I say, let us say for producing any component, you have to spend some amount of money or some cost you have to spend. Okay. So if I say that, optimize the cost, then what you have to do? You have to work, okay, and you have to improve your process and you have to decrease the cost which is involved for production. Okay. Now whenever cost is involved, optimization means minimization. Okay. Now whenever profit is involved, let us say you are selling some components, you are having some manufacturing industry. Okay. Now you are selling some components to some suppliers, or in the market you are selling some components. Okay. Now whenever I say optimize the profit, okay, then what you have to do? You have to maximize the profit, right? So optimization in the sense, some of you might be thinking that it is only maximization. Okay. So most of the students will be having this notion. Okay. Optimization means only maximization, but it is not true, right? Optimization means it may be a maximization, it may be minimization. It depends on the parameter which you are optimizing. Okay. If you are optimizing the production cost, it is minimization problem. If you are optimizing the profits, okay, it becomes a maximization problem. Generally, whatever the process which are involved in industries, we are trying to optimize those processes, right? So maybe optimization of time. Let us say for a process, let us say drilling is a process. Okay. Let us say if you are spending some 2 hours of time on that particular process, so you have to recheck that process. Okay. You have to recheck that process. You have to apply some mathematical tools. Okay. And you have to check whether the time period can be optimized for that process. If it is so, you can decrease the time period for that particular process. Now you are optimizing the time period. That means you are decreasing the time period. Okay. So anyways, you are just finding the best solution. Okay. So you have to find the minimum amount of time in which that particular process can be completed. So as some of you said that best possible solution. Okay. It is also true. Optimization in the sense you are finding the best possible solution for a given problem. Okay. So that means that is known as optimization. So in industrial engineering subject, mostly we are concerned about optimization of processes which are involved in industries. Okay. Now any other objective of this subject? So in one word if I say the objective of this subject, we are worried about increasing the productivity in an industry. Okay. Increasing the productivity in the sense, what do you mean by productivity? Productivity in the sense, production rate we can say, or else productivity in the sense, generally we write productivity like this. So productivity is equal to output divided by input. Okay. So in general, so whenever you go through any textbooks, you will see this part. So I mean definition of productivity. Productivity is equal to output by input, right? So what is the formula for efficiency? It is also output by input, but your efficiency will be less than 1, right? But what about productivity? It should be less than 1 or greater than 1. So please reply. Productivity, it should be less than 1 or greater than 1. So whenever we talk about productivity, our aim should be increasing the productivity. Increasing in the sense, obviously it should be greater than 1. That means, so productivity in the sense, we can say it is rate of production. Okay. So what we are doing in industries, we are going to manufacture some finished goods. Okay. You can take example of any manufacturing industry. Okay. Now let us say this is a pen. So you are having a pen manufacturing industry. Okay. So we are optimizing the process, or else using this industrial engineering subject, we are trying to increase the productivity of this pen. Okay. So increasing the productivity in the sense, already we have discussed, productivity should be greater than 1. The reason is, what is your output in any industry? Your output will be the finished product, right? Finished product. So this is a finished product. So in a pen manufacturing industry, this will be your output. Now what are the inputs to produce this output or finished product? Raw materials, manpower, machine power, everything. So everything will be the input to produce this particular final product, right? So those are your inputs. Okay. So inputs are raw materials, manpower, machine power, and so on. and output will be your finished product, right? Now whenever I say productivity is greater than 1, that means with minimum input, okay, you have to produce a better product. Output should be maximum with minimum input, okay. So what is production? So in each and every stage you are increasing the value of your product or raw material, we can say. So at initial stage you are having a raw material, okay, that will be your input. So this raw material, so raw material for this pen, it will be, let us say, plastic, everything, ink and so on, okay. So initially you are having raw materials, okay. So these raw materials will undergo several processes, okay. So in each and every process some amount of value will be added to this particular raw material, okay. So finally it becomes a finished product, right? So that means in each and every process the value of your raw material is increasing. So finally output, the value of output will be more when compared to the value of the input or your raw materials, okay. So what is meant by increasing productivity? Increasing productivity in the sense with minimum amount of resources you have to produce a better product or your output should be maximum. That is why we are saying that always your productivity should be greater than 1, okay. So in one word, if I want to say the objective of this subject, so this subject deals with or worries about increasing the productivity of an industry. To increase the productivity, you have to use minimum amount of inputs or minimum amount of inputs will be minimum raw materials, minimum manpower or minimum time taken, everything, okay. So that means all the inputs you have to optimize. Is it okay? Now to increase the productivity, we need some mathematical tools and techniques in any industry, okay. So we can, not only for the manufacturing industry, you can consider it as service based industries also, right? For any industry to increase the productivity, you need some mathematical tools and techniques, which are these, okay. So all the topics, all the names, so we have written, so this is the GATE syllabus, right? So now I am changing the term, okay. Now this is not GATE syllabus, these are some mathematical tools and techniques which we are going to use to increase the productivity of an industry, okay. Now what is the aim of this subject? The aim of this subject is to increase the productivity, okay. So to increase the productivity, we need some mathematical tools and techniques. So all these topics, names of the topics which we have written here, all these are some mathematical tools and techniques which are used to increase the productivity of an industry, okay. So increasing the productivity in the sense, indirectly you have to use minimum amount of inputs, okay. So minimum amount of raw material, minimum time you have to use, okay. So you have to use your resources more, I mean you have to optimize your resources, okay, and you have to use your resources more effectively. Some of you are saying effectively, okay. So all these things will be taken care by this particular mathematical tools and techniques. We will use these mathematical tools and techniques to increase the productivity of an industry, okay. So have you understood the aim of this particular subject? So any doubt or in this, what are the things which you have discussed till now, right? So any doubt in this which we have discussed? So I just have discussed what is the aim of this particular subject, okay. So all the topics or all these are mathematical tools and techniques which are just used to increase the productivity. So our main aim of this industrial engineering subject is increase the productivity, and to increase the productivity, use this mathematical tools. Fine. So as you have asked for reference books, so I'll write the names of the reference books. Okay. So I just have highlighted the reference books here. So if you want, you can copy this. So Operations Research by Hiran Gupta. So this is one of the very good book which you can refer. And one more book is Industrial Engineering and Management also. Industrial Engineering and Management by O.P. Khanna. Okay. See, if you are looking for some theoretical part, you can refer this particular textbook. And if you want to practice some extra questions or extra numericals, then you can go for this particular book, Operations Research by Hiran Gupta. So one more book is there, Operations Research by Kanti Swarup. You can also go through that particular book. Okay. So again, no issues. Okay. If you are not having access for this particular books, you can go through any book. Okay. You can go through any book, right? So what are the book maybe which you have followed in your BTech? You can go through the same book. You can follow that book. You can refer those books for any additional questions or anything. Okay. See, reference books in the sense, so I will tell you, okay. So reference books in the sense, the name itself indicates that you have to refer those books. Okay. So in the sense, no need to read from first page to last page. Okay. You will be wasting a lot of time if you are doing this. Don't read from first page to last page. Okay. So if you are reading like that, you will be wasting a lot of time. So reference books in the sense, if you have not understood any particular topic, okay, so maybe, so you may have some confusion in some particular topics, okay, so maybe you can go to that particular textbook and you have to read only that particular topic which you have not understood, okay. So that is the meaning of reference books, okay. So don't read from first page to last page. If you are having any doubt in a particular topic, go through the textbook, okay. So just read that particular topic, okay. No need to read entire textbook. It will take a lot of time and you will waste time, okay. So again, if you want to practice some more questions from any particular topic, okay. So after going through some particular topics, so you might feel that, so I have to solve some more questions on this topic. Then go to the reference books, okay. Solve some questions. But in reference books, you will be finding some conventional type of questions. No need to worry, you can solve those conventional questions also if you want, okay. But in the gate examination, they will be asking some objective questions only, objective or numerical answer type question. That means they will be breaking that conventional type of question into a small part, right. So it is okay, you can go through the textbooks and you can solve some conventional questions also, okay. But you have to take care. What are the topics which we are discussing in the class? Only those topics are there for your gate examination. Don't read any extra topics, okay. So if you want to do anything extra, you can practice more number of questions by going through the textbooks. So let's start with our syllabus. First we will be starting with this part, operations research, okay. And our first chapter will be CPM untitled. So before starting this operations research part, so we will discuss in brief what will be the application of these topics, okay. So already we have seen that the aim of this particular industrial engineering subject is to increase the productivity, okay. To increase the productivity, these are the mathematical tools, okay. Now how can we use these tools in industries to increase the productivity? That we are going to see, okay. So first we will be starting with this part, right. Now we will discuss the application part of these topics or these mathematical tools in industries. That means how to use these particular mathematical tools in industries. Now for this, to understand this, let's take some example, okay. Let us take the example of any manufacturing industry. Like let us take example of manufacturing industry, Bajaj. Okay, so Bajaj is a manufacturing industry, right? Now we know that this manufacturing industry produces so many number of bikes, so many different variants and different types of bikes, okay. Now do you know on an average or roughly how many components will be there in a bike assembly? Roughly, can you guess? So maybe you might have seen some videos also, bike assembly, or maybe some car or any automobile assembly videos, okay. So roughly, can you guess how many components or how many assemblies will be there? Or how many components do we need to assemble a bike? Roughly? Okay. So roughly, you will be having around 40,000 components in a bike assembly. In the sense, so dismantle, from a small nut and bolt, to a big engine, everything, okay. So if you dismantle your bike, okay, roughly around 40,000 components will be there in a bike assembly, okay. So that is a very huge number, right? So to assemble these 40,000 components, you cannot assemble them randomly, okay. That means you have to follow some sequence, right? Otherwise, assembling randomly, it is not possible, it is impossible, okay. So you have to follow some sequence, okay, and you have to assemble those components correctly, okay. Now what will be our aim in assembling these components? Now we are not talking about manufacturing these components, okay. We are just talking about assembling these components, okay. So you are having 40,000 components, okay. Now you have to follow some sequence and you have to assemble those components, right. Now what will be our aim in assembling these components? So our aim will be, we have to assemble these components is in as minimum time as possible, okay. So what will be our aim? Our aim will be to reduce the time taken to assemble. So is it okay getting? So whenever you are assembling these components, so our major aim will be, so by taking minimum amount of time, we have to assemble all these components. Now to do this, your CPM and PERT will help you, okay. So CPM and PERT will help you, it will say in which sequence you have to arrange, okay. So how to arrange everything, okay. So this CPM and PERT will help you in minimizing that particular time. Okay, let us say assembling a bike, it is a project, okay. Now you have to complete that project with minimum amount of time, okay. Now how to assemble all these components with minimum amount of time? You can do that with CPM and PERT. So use this mathematical tool and technique, okay, and you can assemble all those components with minimum amount of time, okay. So not only that bike assembly, any project, okay. So if you are having any project, okay, you can complete that project with minimum amount of time, or else we can say you can find the minimum completion time of the project using CPM and PERT. So in a project you will be having so many subtasks, right? Okay. So you have to follow some sequence and you have to complete all those tasks, okay. This CPM and PERT will help you. So how to complete those tasks, okay, in minimum amount of time. So this is the mathematical tool which will help you to find the minimum completion time of any project. So is it okay? This is the application of CPM and PERT in industries. Network flow models, again it is also a part of this network models, okay. So we are having one chapter in sense, main heading is network models, okay. Under network models we are going to study CPM and PERT, okay, and network flow models also. So again this will be a very small topic. So when we go through, when we start this particular topic, so at that point itself we will discuss the examples or the application of these topics, okay. Now moving to the linear programming. So linear programming, I just have taken this example, right? Now let us say I am just giving you the application part of linear programming, okay. Let us say this company is manufacturing some bikes, so I am just writing some names. Okay, so I just have written some names, okay, some names of the bikes which this industry manufactures, okay. So now on each and every bike, the profit which this company is earning will be different, definitely, okay, as the cost or the price of these bikes are different, definitely the profit which this company is gaining on these bikes, definitely it will be different, okay. So on each and every bike it will be getting some different amount of profits, okay. So similarly the number of units which this company is going to manufacture these bikes will also be different, right. So maybe depending upon the demand in the market, they have to decide how many number of units of each and every bike they have to manufacture. Now let us say this is X1 number of units, X2, X3 and X4, okay. So let us say these are the number of units of bikes which this company is manufacturing. So Pulsar 220, let us say it is X1 number of units, X2 number of units, X3 and X4, okay. So let's Platina nowadays they are not manufacturing, but just for an example we are taking, okay. So now how to decide this number of bikes? So for any manufacturing industry, the main aim of that particular manufacturing industry will be to maximize their profits, right. Now they have to decide these variables. Now we can call them as variables. The number of units of this X1, X2, X3, X4, okay, we can call them as variables, okay. Now they have to decide these variables in such a way that their total profit should be maximum, okay. Now for this particular problem we are talking about optimization of profits, okay. So optimization of profits in the sense maximization of the profit, okay. So we have to find out these variables. So what are these variables? Number of units of each and every bike, okay. So you have to find these variables in such a way that your total profit should be maximum. We are talking about total profit, okay, not individual profits on the bikes, okay. So total profit of the company after selling all these bikes should be maximum. To solve these type of problems we need linear programming, okay. So by using this linear programming you can find out these variables such that you can maximize your total profit, okay. That is the application part of this particular linear programming. So understood? So is it okay? Any doubt? Getting or not? So is there any doubt? If you are having any doubt, you can ask in the application part also. Please don't hesitate, right? So let's move to the next topic, which is transportation models, okay. So transportation models, the name itself indicates transportation. Transportation is movement of or moving of your goods or your finished products from one part or from one city to the other city, okay. Let us say, so in each and every city you cannot establish your manufacturing plants like this. You can take the example of same company, okay. So they cannot establish their manufacturing plants in each and every company, in each and every city all over the India, okay. So they may be having some 2-3 manufacturing plants in some 2-3 cities, okay, maybe like Chennai, Bangalore and Hyderabad, okay. So let us say that they are having some 3 manufacturing plants in India, okay. From those 3 manufacturing plants, they have to supply bikes to all over the India, okay. So they have to supply, they have to transport their finished bikes, okay, to all the cities of India, right. Now whenever you are transporting anything, you have to pay some amount of transportation cost. Now what do you mean by transportation cost? Maybe the cost or wages of the drivers, okay? Maybe the cost involved for purchasing those transportation equipment like heavy vehicles you have to purchase, okay? So for transportation, definitely you have to pay some amount of cost, okay? Now what is the aim of this particular transportation models is you have to minimize the transportation cost, okay? So you have to decide from which city to which city you have to send, okay? So you have to decide in such a way that your total transportation cost is minimum, okay? So to minimize that particular transportation cost, you can use this transportation models, okay? So next, coming to the next topic, which is assignment models. Again, the name says assignment or assigning, okay? Now let us say there are some workers in an industry, okay, and some machines are there. Now you have to assign these workers to the machines. Now each and every worker will be charging wages differently, okay? Now you have to assign these workers to the machines in such a way that your total assignment cost should be minimum. Total assignment cost in the sense, the wages which you are going to pay to this particular workers should be minimum, okay? So you have to find out an optimal assignment which minimizes the total payment of wages, okay? So to optimize this thing, again we can use assignment models, okay? Not only the workers to the laborers, okay? Let us say it is a software industry, okay? Now you can assign some employees to the software projects, okay? So each and every employee will be charging differently. So assign these employees to the projects, okay, in such a way that your total assignment cost or the total wages which you are going to pay to this employee should be minimum, right? So to solve these type of problems, we will be using assignment. Now coming to the queuing theory. So in queuing theory, so any idea what is the application of queuing theory? So please let's interact little bit about this queuing theory. So any idea? I mean, what is the objective of this queuing theory? I mean, why we are studying queuing theory? So we are just discussing in brief, okay? So whenever we enter into the chapter, again I will give some more application of these topics, okay? In detailed discussion we will be having when we start the chapter, okay? As of now, just I am giving some in brief, okay? What are the application or how to use these mathematical tools in industries, okay? So let's come to the queuing theory. Number of customers, number of counters. Very good, okay, Alok, very good, okay? Okay, so coming to your answer, okay, Alok Kumar, very good. So you said that number of counters, okay? So let us say you went to a bank, okay, for depositing money. There you might have seen some 2 counters or 3 counters will be there, okay? Now how to decide these counters? Using queuing theory, you can decide the number of counters. When we start the chapter, we will discuss in detail, okay? I am just giving you the application, just brief application, okay? So to decide this number of counters, you can use queuing theory, okay? So coming to the industries, to decide how many number of machines you have to keep in industries, you can decide using queuing theory, okay? So one more thing, whenever you are in a queue, okay, you can find out what will be the expected waiting time of you in a queue, okay? You can find out the expected waiting time, that means how much time should I wait in a queue, that you can find using queuing theory. Like this, so many applications are there in queuing theory. If you want to relate this queuing theory to industries, so in industries also, so many components will be waiting in front of a machine, okay? So all those components has to be processed in that particular machine, right? Okay, so each and every component, again it is waiting in a queue. Now you can find out the expected waiting time of these components, okay? After finding the expected waiting times, you can try to minimize the waiting times, okay? So for that purpose, you can use queuing theory, right? So these are the applications of these topics in industries. So we will be starting with operations research. First chapter, CPM and PERT. So you can keep heading CPM and PERT. So any doubt in this till now, whatever we have discussed? So is there any doubt? If you want to ask any questions, you can ask. Or if you are done, please keep the heading chapter 1, CPM and PERT.